This lesson will focus on simultaneous equations type 3 from National 5. Example 1. Solve the following pair of equations. 3x add 2y equaling 14 and 2x subtract 3y equaling 5.
In example 1, we've been given two equations with two unknown variables, therefore that should make us think that we must solve these simultaneously. To do this, we must have same coefficient yet different signs. Look at both of your terms to see if there's one that maybe helps you start off. Now, I would always look at the middle one first of all. It just makes it easier to always have a focus. In the middle here, you'll see that we've got different signs. So that's one of our things already taken care of. The next thing we have to have is the same coefficient, which you'll see here we don't have. We now know that we can scale up the equations to allow us to get these properties of same coefficient yet different signs. To do this, let's begin once again and just separate our sets of equations off. So we need these two to have the same coefficient. So if you were to go through your 2 times table, your 3 times table, you'll get a match at the number 6. So that therefore means I'm going to multiply this top equation by 3 and I'm going to multiply the bottom equation by 2. So let's go through this to scale them up. Multiply everything by 3. 9x add 6y is equal to 42. Now if this is a non-calculator and you struggle to do that in your head, do it at the side, it's not an issue. Next one, multiply everything through by 2. 4x subtract 6y is equal to 10. At that stage there, we have the same coefficient yet different signs. So in that case there, let's just take a ruler and separate our sets of equations off. When we have that, we should always be thinking that we must add our equations together. So we're going to add 9x add 4x gives me 13x. Positive 6y add negative 6y eliminates, which is ideal for us. And then we add here 42 and 10, which gives us 52. From there, we've now eliminated one of the variables, so it makes it really easy to solve for the other. X is equal to 52 over 13, which we know is 4. Once we've solved for one variable, we solve for the other variable. Let's take it and put it into the very first equation. So therefore, we've got 3x add the 2y is equal to 14. And we want to solve when x equals 4. So sub it in. 3 multiplied by 4 add 2y is 14. That's just a standard equation which we can solve. 12 adding 2y is 14. I will take my 12 over to the other side, which becomes subtract. So 14 subtract 12. So that gives us 2y is equal to 2, which means y is equal to 1. Therefore, x is equal to 4 and y is equal to 1. You can always check these by substituting them back into the very first equation if you so wished, or even the second one. If we looked here, 3 multiplied by 4 is 12, adding 2 multiplied by 1 is 2, 12 add 2 is 14, so that means we've done it correct.
Example 2. Solve the following pair of equations. 6e add 4f equaling 14 and 5e add 2f equaling 13.
Once again, in example 2, we've been given two equations, two unknown variables that we want to solve for. To do this, we should now definitely know we're going to solve them simultaneously. We're going to try and eliminate a variable, so therefore we're checking for same coefficients, yet different signs. You'll see here we've got neither of that. We don't have a same coefficient, we don't have different signs, so we're going to have to make it that way. So to begin with, let's just separate off our first set of equations. Okay, again, I just tend to like to go for the middle one. It's totally up to yourself. What I need to do here is I need to get, first of all, let's just build the same coefficient. So to do that, I will look at, right, I've got 4 and 2. So I could scale the second equation up by a factor of 2. So here, multiply by 1, so that keeps it the exact same. Second equation, let's multiply by 2. Okay, we're going to have 6e adding 4f, and that is equal to 14. Second equation, 10e adding on 4f is equal to 26. Now right away, draw your line, just to keep them separate for me, guys. Okay, at that stage, you want to now have different signs. So if we look here, we've got the same coefficient, we've got the same signs. So all I'm going to simply ask you to do is change the sign of everything in the bottom line, which is just the same as multiplying it by -1. So top line stays the same. 6e add 4f is 14. Deal with the bottom line, -10e subtract 4f is equal to -26. Again, take your ruler and separate them. Okay, we're doing our final check here. We've got same coefficient, yet different signs. So when that's the case, we now know that we can simply just add them together. 6e add -10e becomes -4e. That eliminates, so it now equals, then we've got 14 add -26. That's the same as 14 take away 26. So that's going to give me an answer of -12. From there, let's then solve. We have e is equal to -12, oh, just wrote that the wrong way, divided by -4. That means that e will be a value of 3. Now that we've solved for the unknown term e, we're now going to solve for the other one, which is f. So let's begin with our top equation. So that was 6e adding 4f is equal to 14. So when e equals 3, I can now substitute in. So I have 6 multiplied by 3, add 4f is equal to 14. 18 add 4f is 14. I'm going to take my positive 18 over and make it -18. 4f is 14 subtract 18. 4f is -4, so f is -1. Therefore, e is equal to 3, f is equal to -1.